Are my judges ready?
Yes.
Hello, my name is Jesse Williams, and this is my senior project, hot rod guided welding. Stick welding is most efficiently used for pipe welding in the field. For my senior project, I decided to build a roll bar for my 1984 Chevy four-wheel drive truck. It has a 4-inch lift and it is very squirrely, so it can tip over easily, more easy than other vehicles. I decided to do something along the lines of designing and building with pipe because last summer some of my friends built a meat smoker out of a propane tank, which is a very large pipe cylinder. There are very many different types of welding, but the most common three are stick welding, shielded metal arc welding, MIG welding, gas metal arc welding, and TIG welding, gas tungsten arc welding. Most molten pools are called beads, and this is what they generally look like. There's the face of the weld, there's the toe, which is overlap, the root is the very bottom, what is laid down first, and the fusion zone, also known as penetration, how deep it is. I used stick welding for my project because it is normally known for pipe welding. There are very many different electrodes or rods for stick welding. Some of the common ones are 6010, 6011, 7013, 7018, and 7024, which is jet rod. They have different meanings. The E, electrode, stands for, or just the electrode. The first two digits stand for the tensile strength, the minimum tensile strength in kilopound per square inch. The third digit is one, is an all-around, all-position weld for 6011 or 6010, 7018. They're mostly for all positions. The very last digit is for the type of coating and the current. Alternating current, direct current positive, and direct current negative. Direct current negative is more commonly used for TIG welding, but is also used for stick welding. There are very many different positions. There are fillet welds and groove welds. Fillet welds are for more starters. Flat position is 1F, 2F is horizontal position, 3F is vertical position, 4F is overhead welding. For your groove welds, or fillet welds they have a side plate and a bottom plate, so it transforms a T. Groove welds are flat steel and they have beveled edges so that there is room for the bead to go down. They are used for bend test, where they cut slots out and use them to bend at 30 tons. 1G, 2G, 3G, and 4G. Still flat, horizontal, vertical, and overhead. 1G, 2G, 5G, and 6G are for pipe, and pipe welding is a little bit more difficult because in those positions they have to stay the exact same. You can't rotate the pipe as being moved. You have to go all the way around. My senior project, I built a roll bar, and it was a little bit difficult. I had to decide what it was going to look like and figure out how I was going to build it. The first thing I had to do was blueprinting. This is a lot more complicated than needed, but the ideal of it is the reference line has where it has options of fillet weld or weld symbols on the top and bottom. The arrow side is on the bottom, where the joint of the weld is. The other side is known as the other side. The circle stands for field, all the way around weld, which is most common on pipe. The flag is for field weld, so if you had a 20-foot stick of pipe that needed to be welded to another 20-foot stick of pipe, it would need to be welded at point B and brought in 20-foot links from point A to be welded at point B. After I learned some of the blueprinting, I had to take measurements of the back of the truck and do quite a bit of math to find out the exact precise links that I should cut my metal into. After I had my metal cut into lengths, I had to cut angles, and that was by far the hardest thing I have done. Once I got the angles cut, I had to make sure that it all fit together perfectly, and I tack weld it all together and make sure that it would be exactly what I measured out and that it fitted up into the back of my truck just perfect. A pass is also a molten full metal or a bead, a weld bead. The root pass is always the very first pass on welding, and it goes at the very bottom. This is a flat plate, which would be like a 1G or 2G, 3G or 4G. The root pass always goes first, and then the hot pass or the cap pass will sometimes be the same pass if it's on flat material. If it was like being welded just on a butt weld, it would be cap pass or the fill pass, or the hot pass or the cap pass would be the same thing. But on a bevel or groove, it will need fill passes, which is just pretty much to get it centered back up to the very top. That is the overlap or the toe. It's how far the weld goes out onto the material being welded. After I tack welded it all together and made sure it fit perfectly, I had to weld it together. It was a little bit difficult because my angles were not perfect and I had some 1/4-inch gaps or a little bit bigger. And it is pipe, and I've never welded pipe before, so that made it a little bit more difficult. I wasn't thinking that it was going to be as difficult as it was, which is kind of why I did it. After I welded it all together, I had to clean the welds up and make sure that they were pretty and that it looked like it was just from the factory. Thank you. Do you guys have any questions?
I have a question. Had you done much welding prior to this project?
I've done a little bit of welding, just not very much. I haven't really done any welding on pipe, but on like flat steel, I've done a little bit.
I see, so a lot of this was new for you.
Yes.
So, thank you.
What classes or teachers gave you guidance or support in this project?
None really. I had VOTEC last year in school, and Mr. Dye, he was the teacher for the welding program, and he kind of helped out a lot with me learning a little bit more about welding and blueprinting. He was.
You said that cutting the angles was probably the toughest challenge.
Yes, sir.
Did you have to just do trial and error, or did you get the math figured out?
Trial and error, kind of.
Okay.
I wasn't sure. Me and my dad actually got into a little bit of a dispute over what angle that they should be cut, because I thought 45 just need 2 45s to make it 90, but he pointed out that a 45 will not just go to another flat piece because it would have offset, and so he proved that 22, it would need 4 22 and a half degree angles to be cut to make a perfect 90. So that's a 22 and a half degree angle, and that is 2. And I had 4 of them, 2 there, and then there's 2 there. So that makes a 90 degree.
You plan to go to welding school after high school?
Yes, sir. May 21st at MWI.
MWI.
Supposed to start. Is there any more questions?
Do you have a little more respect for your geometry teacher at this point?
Yes.
Just check.
You're good.
He's not scoring you, so.
We got it.